Hello everyone and welcome to my session. Hopefully, as you can guess from the title, we're going to be talking about SQL Server availability groups. This session is aimed really at dummies, so it's really aimed towards people that have never used availability groups or are looking to use it and want a little bit of a head start. This session is not really aimed at explaining all the new functionality of availability groups. I want to really give you the grounding and just enough to get started. So the session will include lots of scripts as well that you can try at your leisure and break at your leisure, as the case may be. So there's not really much to talk about on this slide other than the fact that if you do have any follow-up questions you want to ask me, then feel free to send me an email. I'd probably prefer email, to be honest, but you can also tweet me if it's a really quick question. Nothing more to say about myself. I'm not that interesting, so let's crack on with the session. So what are we going to be talking about today? Well, clearly SQL Server availability groups. We're going to first touch upon really how SQL Server high availability and disaster recovery really came about and how we've got to where we've got to today. We're then going to be talking about really probably I would say the hardest thing in all of this is preparing your Windows servers and your SQL Server availability group prerequisites. We're then going to really focus on how on earth do we implement availability groups, and then we're going to finally look at some of the benefits of availability groups and what we can actually utilize these things for. Clearly we've got HA when we set the things up, but we've also got some scale and we can offload backups and a few other things. So we'll look at that in a bit more detail. So in the beginning, SQL Server 6 first implemented replication, and replication I tend to think of as more of a data level type of HA. It's kind of HA because you're essentially taking a copy of a table or a subset of data in that table, or even many tables in your publication, and these are being replicated out to subscribers. I'm sure most of you are familiar with replication, and it's regarded by many as a really cool technology. I regard it with a lot of fear. I've run into a lot of problems with replication in the past. In NT4, so in 1997, this was really my first introduction with availability in SQL Server, because with NT4 Enterprise Edition, it introduced a technology that was called Wolfpack, which was really the clustering, NT4 clustering. And what that allowed us to do is to run a SQL Server instance in that cluster. There was limitations behind that technology. One, you could only have one SQL Server instance. That was more of a limitation of SQL Server though than clustering. And the other thing was you could only have two physical nodes. So if you had one physical server failure, then you'd fail over to another server. So it worked, but it was not without its problems, and all the plumbing as well was very physical. There's clearly no access to anything in the cloud, which made things a lot easier. So then what happened? In 2000, with SQL Server 2000 and also 2005, there were some updates to replication that actually made those technologies a lot more compelling to use. But again, we're still only talking about a data level of availability. And really what we're wanting is some kind of database abstraction, a database level of availability, and that actually came in SQL Server 2005 with database mirroring. Now, I was a big fan of database mirroring. It was fairly simple to set up, and it did exactly what it said on the tin. It did come with a limitation though, and that was that you couldn't query the copy, the secondary database mirror. You couldn't query that database unless you dynamically created a snapshot on that mirror database, and you were restricted to just that one mirror as well. So it wasn't fantastic, but it gave us something, gave us a little bit of scale, a little bit of HA, or a lot of HA, but it again had problems. So in 2012 we had availability groups. It was touted as being unicorns and rainbows, and In reality, it isn't quite that. I've not been the biggest fan of availability groups. Certainly when it first came out, I'm warming to it a lot more now. I think things are getting a lot easier to set up. So what this really provided us, it was an extension of database mirroring, or it kind of appeared like as an extension of database mirroring because it seemed to replace it. And indeed, Microsoft with SQL Server 2012 release said that database mirroring would be deprecated within 3 versions. Now that's not really, the removal of database mirroring has not really happened. But clearly it has been deprecated. And with SQL Server 2016, we had the introduction of a technology called BAGs, or Basic Availability Groups, which allowed us to say a final goodbye to database mirroring as a consideration for HA. But we'll talk about that a bit later. So availability groups you can almost think of as being not just a database level abstraction for your availability, but a multiple database level abstraction. So if we had a failure on one server, we want to fail over a group of databases as a unit to another server or another node. And this is what it allows. But just having one failover partner is clearly not amazing. Availability groups lets us have many. We'll talk about that a bit more later on. So when you first want to get going with availability groups, if you're starting from completely afresh, then you'll have to follow all these steps. Now clearly there will be some scenarios where you have an existing server where you want to set up availability groups. So you might have a SQL server already, which you think, well, I want to enable availability groups for this. Well, what that will mean is obviously you'll need a second server that's set up and configured and ready to go as well. So I've just pointed out on this slide that you'll see the little asterisk 1. So just bear in mind, if you already have these things in place, you don't need to do these steps. It's pretty much common sense, but obviously bear that one in mind. Now let's say I'm starting out afresh. I've got 2 completely, well no actually let's say we've got 3 completely new servers. Well, the first thing we obviously want to do is set up Windows on these servers. Okay. Once you've got Windows set up on these servers, you then must set up the failover clustering feature. So you need to enable it, and there's a couple of ways of doing this. Probably the easiest way to do it is to use, well I find it the easiest, is to use this PowerShell command add Windows feature and select the failover clustering module and include all the sub features. And I like to include the management tools if you are using the GUI version of Windows, because I think having the failover clustering manager GUI is quite useful to me, certainly for troubleshooting. You could alternatively just configure that through the GUI, as I'm sure you've configured other features in the past through the GUI, and there are a few ways such as DISM and a couple of other ways to do that, but those are the 2 key ones. Once all your servers that are going to be part of your availability group are set up with the failover clustering feature, the next thing you clearly will need to do at some point is to create your Windows cluster across the servers. Right. Now, the probably easiest way to create your cluster is to use the failover cluster manager. You can simply say create cluster. I'll show you this later. Create cluster. You specify what servers are going to be nodes of the cluster, and then you give it a cluster name and an IP address, and then you've created the cluster. It's as simple as that. Now let's just assume that you were starting afresh, so clearly the next thing we will need is SQL Server on all of these servers. So what we want to do in the ideal scenario, we want a locally installed instance of SQL Server, a standalone copy of SQL Server on each of these servers which have been configured as cluster nodes. Now this is not the same as a failover clustered instance of SQL Server. We are not installing anything into the cluster. What we're doing is installing SQL Server on a cluster node, and then SQL Server will be connecting and coordinating stuff with the cluster node, but that will become clear shortly how that all works. And then the final thing that we need to do is to enable the always on availability groups option for each of those SQL instance services. And this is the thing that will allow the SQL service to interact with the cluster service. It's a very important thing to do and probably quite easily missed. And you can enable this again through PowerShell and a few other mechanisms. I actually just like doing it through the SQL Server Configuration Manager. It's a much easier way just to go, yep, there, click, 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 done. Okay, you will need to restart your SQL service though once you've done that, and probably the best time to do that is straight after clicking those buttons, just so you don't forget to do any. And then there's a final task that you may want to do. This is really one for your cluster admin. You need to work closely with your cluster admin on all of this to make sure they understand what you're doing. But we have this concept in clustering called quorum, which means that we have this voting mechanism or quorum, which allows us to configure the cluster in such a way that every cluster node knows whether A, it belongs to the cluster, B, still belongs to the cluster, and C, which other servers currently belong to the cluster, because we could have an outage or we could have a network connectivity problem between two servers, and both of those may need arbitration to understand, am I still part of the cluster and are these other servers part of the cluster? So this is really just what quorum is. And we also can do something called node weighting in the quorum, so we can actually specify that various nodes have no ability to vote in the quorum. But that's generally something you probably won't need to worry about. It's something that you should know about, but not necessarily something you should know about, or should know how to do, should I say. And then the final thing we will need to do is we need to configure all the prerequisites in SQL Server to allow us to now create our availability group. We're pretty much ready to go as we are, but we need to create all the underlying security structures in order to just create the availability group. Okay, that will become clear in a demo very, very shortly. Now, I just want to touch upon troubleshooting your cluster, because this is not necessarily clear to us people who are SQL Server gurus, if we're not also clustering gurus, that there will be times where you have problems with your availability group, and certainly there will be problems where you have problems more specifically with your cluster. You may not be able to connect your cluster for whatever reason. It's important you understand how to be able to do so. Now, if you know or remember that we created a cluster name and cluster IP when we set up our cluster, you can have a situation where your cluster name is down, but your cluster IP is still up. So clearly, if your cluster name is down and you are trying to connect your cluster in your cluster admin tool, then that's not going to work. But if you then specify your cluster IP instead, it will, of course, still be able to connect to your cluster, and you can resolve any issues, and you'll still be able to view what's going on in your cluster. There is another technique slightly beyond that, that if even that way you cannot connect into your cluster, you can go onto one of your cluster nodes and do a connect within your cluster admin tool and just use a period or a dot, and that will say to the tool, I want to connect to this cluster which this server is part of, and that again will direct you into the cluster, and it should hopefully load up everything in your failover cluster admin tool, and you could hopefully then see what problems are currently happening. If there is a problem beyond that, then you can also use the failover clustering commandlets for PowerShell, where to view all the configuration of your cluster. You can see what nodes are currently up or down, what resources are currently up or down, and many other things. You can do lots of configurations, and I've used all of those techniques to troubleshoot clusters and availability groups in the past, and it's really useful to know that. So just bear that one in mind. I would also suggest that your cluster admin, your cluster guru in your workplace should know how to do all this stuff, but a lot of them, from my experience, generally don't. So we're now going to go into the first demo. I'm going to show you a few things in the GUI regarding setting up your cluster, and then we're going to run the first demo file, which is our sort of security SQL prerequisites. So the first thing I want to show you is if we go to the SQL Server Configuration Manager, you'll see within SQL Server Services, we can see our SQL Server service here. If we do a properties on it, I've already done this, of course, because the cluster is set up, but you'll see that my failover cluster is called cluster 1, and for this standalone instance of SQL Server, I've simply said enable always on availability groups, if you remember me doing that in the slide earlier, and then of course that service would go through its restart. So that's the first thing we needed to point out. Now, before you did that though, you probably want to know, in fact, let's do that in my server 1. So we're in Failover Cluster Manager, as you can see here, and this cluster 1 is what I've created. So we've essentially done a, if we right click there, you can see create cluster, and we specify the name and the IP address, and we specified the nodes, and that would get us to a state where all our nodes are currently configured in the cluster. And we shouldn't have anything in rules at this stage, okay? So that is all you would do to create your cluster. You simply just do this, create cluster, add your nodes in, and prior to that you'd add your cluster name and IP address, and you should hopefully be good to go. It's probably worth saying when you're setting up a test environment, tell it not to do validation, because that will take a long time and will come up with lots of errors as well. So once that's all done, we are essentially ready to go. Let me tell you that there is a script here called Teardown, which will undo everything that you change in your environment. Please don't do any of this in a production environment though. So we're going to hop straight into prepare environment for AGs. Okay, so this is all SQL Server security configuration stuff. It's worth me pointing out that I'm using SQL command mode so that we will connect to a server, run some code in that server, and the Go is the batch separator. So essentially this block will get sent to the server. All right, to enable that, we click on there, and we're now ready to go. So the first thing we're going to do is create database master keys in master on each instance. And the reason we're doing that is we want to encrypt our keys, our certificates when we create them. Okay. So this is connected to server 2, 3, and 4 and created those master keys. The next thing we want to do is create our certificates in a similar way in master. And when that's done, the other thing that we're going to do, we need endpoints in order for the instances to communicate to each other. This is exactly the same in database mirroring. You'll even see this keyword for database mirroring, which is also piggybacked using for availability groups. So we're going to do those, and you'll see that I'm using encryption and logarithm here, and we're using certificate-based authentication. Yes. So server 2, 3, 4. Now I've got a couple of helper files for you set up, save you messing around with these. And if I go into here, what we want to do is, I believe they're batch files. So let's just go cd into batch. So what we have is a couple of scripts, and the first one, I just want to delete all the existing certificates that I may have run in a previous demo. Let's do that. Sorry, that was the wrong one, but I wanted to do that anyway, the backup files. And there we go. It says deleting the certificates across the servers. You'll notice there's lots of rems because a lot of these servers I haven't set up for these demos. Now we've got our certificates in place, so what we're going to do is we're going to back up for each server each certificate and to a central location. We will at some stage use the necessary certificates and bring them into that server, but that will become clear what we're doing there in a second. Notice also we have specified a private key file as well to output. So again, those 3 servers, we've done that. Now the next command I've got is just a helper command again to copy those certificates. And the reason we have to do that is it's a security mechanism in SQL Server that it will not import a certificate that is not local to it. Hopefully that's obvious why that might be a problem if it could do remote paths. Now this takes a little bit of time. Excellent. So we've now copied to every server. I noticed a little typo here. It says 3 when it should actually say 4, but this is correct. They have gone to the right place. I'll fix a script for you guys. So please forgive me on that one. So now we've copied the certificates. What we want to do is create logins that we can use for the certificate of authentication. So we're going to again do 2, 3 and 4, but notice that I'm only creating the respective logins for the other servers on each server. So on this server 3 we're only doing 2 and 4 and so on. And then the next thing we need to do is create users for the login. And then finally, what we do need to do is, if you remember, we have just copied those certificates across locally to each server. We need to create those certificates from those files. Okay, so this is what we're doing here. Worth noting that you might have been thinking above, why are we creating these users? And this is why. Okay, this is where the authorization happens. So there's quite a bit of text there, but hopefully it all makes sense. And then the final thing we need to do is we need to grant connect rights to the endpoints for those respective logins. Again, notice that 2 only contains a grant for 3 and 4. Hopefully that's common sense what we're doing there. Now that might have seemed a little bit convoluted to you all, and I would say yes, it clearly is a little bit convoluted, but this is the best practice of how to set security up for an availability group. I have to confess that for database mirroring and availability groups in the past, I have cheated. It's very easy for you to use you could either use a server admin, which is configured on each instance, or another account which is an admin on each instance, and just simply create the endpoints and grant connect rights to that. But that is obviously a potential security risk, which is why we're doing the best practices here. If you're going to do something, then do it properly, is what I say. Now I've set up the prerequisites for availability groups and given you a very, very quick overview of what an availability group is, but let's just delve into slightly more detail of what an availability group is and what it consists of. So as I said earlier, we can have not just one copy of our database or databases, we can have many copies or of our availability group, and each server that participates in hosting a copy is called a replica. And depending on what version of SQL Server you're using, the number of replicas that you can have will depend. Your your primary replica is called the primary replica, and it may not be any surprise to you that the others are called secondary replicas. Okay. Now you can see also that in terms of SQL Server instance components, we've already created our mirroring endpoints for the availability group, and we've not seen this yet, but we would have our database or databases that would become part of our availability group databases. But in order to have availability group databases, we need an availability group. All right, so that's another thing that you'd configure through the instance. What the listener and availability group will do if we create them through the instance behind the scenes, that will go off and create those clustered components. And it's worth me pointing out, do not ever let your cluster admin touch those components in any way, shape or form. All the configuration must be done through SQL Server. Okay, I have not really talked about listener at this moment in time. I will touch upon it in the next slide. So with our applications, we may want it to automatically and transparently redirect and connect to another replica, because it may be that the instance server A goes down for whatever reason, or we may be wanting to do maintenance on it, so we would want to fail over to server B in our availability group. Server B would then become the primary replica, which means that our applications we would want to transparently redirect, and this is where the listener comes in. It's a clustered resource, and that will automatically redirect traffic to the correct running SQL Server instance that is hosting the primary replica. It's just a piece of cluster magic behind the scenes, and when you get really good at clustering, you'll understand what's going on. It's essentially the IP addresses being owned by the correct network adapter on the correct server. Nothing too technical really is going on. One thing you may have just seen when we did our failover, whether it was an automatic failover due to a failover or it could have been a manual failover, we see that our replication traffic, assuming that our now new secondary replica or replicas are up and running, our synchronization of our transaction logs or asynchronous copying of our transaction logs are now going the other way. Okay, so this is the whole point of availability groups, is to try and make things as automatic and transparent as possible. Now this slide is a little bit more complicated than it really needs to be. The whole point of this slide is really just to indicate to you guys that one of the common failings with availability groups is this common perception that if I query a secondary replica, which are known as readable replicas, if I'm using a synchronous secondary replica, which means that the secondary replica is in sync, you would by definition presume that if you're querying the secondary, you are getting a point in time correct piece of information back from that secondary. In reality, whilst it's almost true, it's not quite, because the problem is that the only guarantee with a synchronous secondary replica is that your transaction log will be up to date. It will have those correct records shipped. Now behind the scenes you have this thing called the redo thread, which is working away, and it's simply taking these records from the transaction log and then applying it to the secondary replica database or databases. So bear in mind there can be a slight piece of latency. Don't ever think that you can, with 100% certainty, query a secondary replica for some information and make a decision and write to your primary replica based upon that information being 100% accurate. Okay, it'll be consistent, but it won't necessarily be point in time accurate. I've generally found that actually going back in time with SQL Server now, in terms of finding out what capabilities certain technologies had in certain versions, is getting harder and harder, because Microsoft seems to be getting rid of the classic drop down that it used to have to choose between the versions for a specific piece of technology and functionality. They tend to now have documentation which is current and correct for the most recent release, which makes it very difficult to come up with this kind of information here, but hopefully I've got it as accurate as I possibly could have done, and it's certainly based upon my memories since SQL Server 2012. There's a few things to point out here. As the versions have increased, going all the way up to SQL Server 2019 now, you'll notice that the possible replica count has gone up. So if we start in SQL Server 2012, you can see that we had a total maximum of 5 replicas allowed in our availability group, 2 of which could be synchronous, and the other 3, of course, would be asynchronous. Okay, so the 2 that are synchronous would be your primary and a secondary. So it would mean that you'd only be able to have automatic failover on the secondary. Okay. Now, if both servers blew up at the same time, you might have problems. You might lose data then, because the others would be in async. Now, going up to 2019, we can have a maximum of 5 synchronous. Okay, so there's a much richer ability there. There's a couple of other things to point out here. You'll notice as of SQL Server 2016, we had basic availability groups introduced, which was really touted as being the replacement, the de facto replacement for database mirroring, because it pretty much gave us everything database mirroring had in availability groups. So this comes with standard edition. It's worth also pointing out that basic availability groups is technically exactly the same as availability groups in enterprise, albeit with lots of restrictions under the covers. And those restrictions, you could just think again of database mirroring. Okay. There's probably a few more things to point out. The first being that with SQL Server 2017, we had the support of SQL Server on Linux and the ability to do availability groups on there, which we're not covering in today's session. And another technology was a lot of people getting quite excited about, which is not currently supporting availability groups, and that is availability groups on Kubernetes. And it's believed that this will sooner or later come, but I've not seen any notification yet that this is going to happen anytime soon in SQL Server, although that technology is currently there in big data clusters. Let's talk a little bit more on basic availability groups. I've already said that it's the standard edition version of availability groups. You can only have those 2 replicas. Your secondary replica it cannot be a readable secondary. Okay, and you can't offload your backups, and you can't use that secondary as a readable replica for the reasons I've just said to you. But very much like database mirroring, you could create a snapshot against it and then read the data, but you are potentially breaking licensing agreements if you're not paying for that standby. Bear that one in mind. Let's go back into our next demo. Okay, so let's load up our second script. And again, we're going to go into SQL command mode. And the first piece of the script you're not going to really need to run, but it's what I just used to have a quick look at, did I create everything that I wanted to create? So the top one I can see in my database. Let's just refresh here because I did drop it earlier and that's now gone. So that explains why that's blank, so that's good. Obviously in a production system you're going to be starting out with databases to do this too, so don't worry too much about this, but please do not run these scripts on a production database. Please know what you're doing there. Okay, so everything else looks good to me. And we don't need to do the top bit. We're going to do it anyway. And then we're going to create our database. It's going to be part of our availability group. And we're going to set it to full recovery mode. And then we're going to create a table in it and then insert some records into it. Okay. So there we go. I'll just make sure the database does show up on 2. Now the next thing we're going to do, we're going to consider this is our future primary replica database. Okay, so let's just create a backup of the database and then backup of its log. And then we're going to take that database, and we're going to restore it with no recovery, and we're then going to do the same with log with no recovery, and we're going to do it for all the other 2 servers that are going to be part of our availability group. So I'll just quickly connect to one of the others. I think it's server 3 like that, and you should see that database in restoring mode there. Now the next bit, it looks quite a complicated statement. All of this stuff can be done through the GUI. It's worth saying all of these scripts can be done through the GUI. I'll just point out a couple of things here. So in this specific case, we don't want DTC support, so we don't want distributed transaction support for this availability group, so that's why we're setting that. And we are simply setting the replica endpoint URLs in the statement too, with various other pieces of configuration, okay, that you can review to your leisure. So let's just run that through. So we're doing this against our primary replica. So if I just do a refresh on that, you will see that that now has gone to synchronized. What we should now have down here is our brand new availability group. So great, we've done now, haven't we, surely? Well, if we right click this and click on show dashboard, it will show us that there are some problems. Okay, what could that be? So let me also show you, if we go to the failover cluster admin tool, you can see that SQL Server has communicated with the cluster and created a clustered resource for your availability group, which is running, currently owned by server 2. Well, what could be running is we've not actually specified on the other SQL instances to join that replica, even though we've put in the right configurations on the what is the primary replica now. We've not done anything on this, what will be the secondary. So we'll tell that instance to join. And I'm not going to do this yet. We'll do it in a second. I'm going to then tell the second one to join. So that's so now we should have 2, 3, and 4, which are correctly configured replicas. Let's have a look at our dashboard and force a refresh. And something's a bit better now. We've got the yellow alerts. Okay, we haven't got anything critical in here. So what else can be wrong? So we can see, actually, if I just flip back, sorry if I keep flicking backwards, we can see that there is a problem here with synchronization. Okay, although that our replicas are correctly configured. So what this is we simply have to say for our availability group database replica, or replica database should I say, we need to join it on server 3. Flip back, do a refresh. That looks good. One more to go, which is this one. And everything's right with the world now. Now, if you are of a certain mindset, you might want to try doing that with the GUI. If you do want to do that, then you can follow this instruction, but this is homework for you. Okay, I would actually say the GUI is quite nice to configure availability groups now. You could use what's known as direct seeding, which will do all the backing up and restoring nonsense for you. But I think it's important for you to understand what's happening behind the scenes, because it's kind of doing what we've done, albeit manually, behind the scenes. Now there is actually one optional thing for us to do, which is do we want a listener? And in our specific case, yes, I do. You could, of course, still connect to server 2 or server 3 or even server 4 directly if you want, but for our application, I want us to have connection availability. I want our connections to be redirected transparently if we have a failover. So I'm going to add a listener. It's as simple as that. And now if we go back into the cluster admin, you can't see that something's changed yet, but if I click on here, you'll realize that we have actually got our listener now and it's online. There's our IP address that we specified. Okay. So that's our availability group created and set up. So that's pretty darn easy, wasn't it? Now, I've kind of touched upon in my spiel that we have these things called readable secondaries. What exactly are readable secondaries? It just simply means that if you query a secondary database in an availability group, you can read it. So that's what a readable secondary is. And this is quite useful because it means you can offload your reads and writes. Okay, there are a few considerations to watch out for. The main one of which is if you are still using pessimistic isolation, so you're not using read committed, snapshot isolation, or indeed snapshot isolation, by enabling a readable secondary, it means for those databases that are part of that availability group, it will have to push out a every time you do an update to data behind the scenes, it will create a version pointer for each row. And that's what happens for snapshot isolation, because for your readable secondary, snapshot isolation is used behind the scenes. So we need that in place. So you could have data bloat a little bit, and you could have a risk of page splits going on. And there is obviously, of course, a little bit IO overhead from doing this. There are a few other things to concern yourself about, and also please do not think just because you have a readable secondary you can just query the readable secondary with absolutely zero potential for ever getting blocked ever in your life again, because that's not the case. There are some DDL operations that could actually block you on a secondary as well, which is listed in this slide. Okay, but you can see in the diagram below that the setting a readable secondary is as simple as going to the replica in question for that secondary rule, just specifying that it is a readable secondary, or that there is or that you want read intent. But we'll see that shortly. Now, another quite cool thing with secondary replicas is you can offload your backups. You don't necessarily want to be continually backing up on your primary replicas all the time, because it is obviously a performance hit to that server. We want to service traffic as fastly as possible for our applications, as for our writes, and we don't want to add any extra burden. So we can offload our backups, and we can do that in I'd say a semi-automatic way, because we do have to code for it, and we'll see this in a demo in a little bit. But what this really means is we can set up backup priorities for our replicas, and we can offload our backups to whatever server that we want to perform backups on. By default, though, secondary replicas are preferred. We'll see what preferred means shortly. It's worth mentioning that you cannot perform a differential backup on a secondary replica, and you cannot perform a full either unless you use the copy only statement. Now, bear in mind, if you are using the copy only statement, that full backup that you take cannot be used as a differential base. In other words, you cannot restore that full backup and then restore a differential that you may have taken on the primary on top of it to get to that certain point in time. All right, but you could apply your transaction logs to it if you wanted. So, but please just bear that one in mind, that you may want to offload that full and use copy only, but every now and again you will want to do a full on the primary, depending on how big your database is, and use differential strategies. But that's something to consider. Slightly more complicated, we've touched upon this earlier as well, is read-only routing and load balancing. So what we can do for our our replicas is we can configure read-only routing lists to them. So depending on which server you're connecting to, you might have a different routing list to other servers, and this will mean that you can your queries could be routed to different servers in turn: server 2, server 3, server 4. Okay, and we can have load balance sets there. So if those are unavailable, you might then go to server 5, server 6. So these secondary rules have to be configured with read-only routing URLs, which you'll see in the code when we come to do it. And in order to use read-only routing, I mean, I've had problems trying to get this working in the past, but there are a few key things you have to do. You have to connect via a listener, and you have to ensure that your connection string is specifying application intent equals read-only. And your load balance sets have to use parentheses to block them off and make it clear that they are part of the load balance sets. If you do have an availability group with lots of replicas and want to use load balance sets, I suggest you go and read a bit more on exactly how that works, because it's a little bit difficult to comprehend just by looking at this. So going back into demo, we will now have a look at this read-only routing and backups. So first thing we're going to do is look at backup priorities. Now what I want to do here is simply run this code across each of my instances, and I'm going to run this function to see if this server is being flagged as a preferred server for preferred replica for backup. Okay, so we'll do that for every single server, and let's see what it says. Interestingly, our primary replica is coming back as 0, and our two secondaries are coming back as being is preferred. So in code, what we would then do is, if we had deployment on each server SQL agent, we would check in code, is it preferred backup, and then we could get the backup to run if it's preferred and to ignore the backup if it isn't. But you do have to code in that logic yourself. Now, if we actually have a look on the availability group itself, we can have a look in the GUI where that is. So interestingly, we can see, and if you remember, I actually said this was default, prefer secondary. Now, what this is saying is we want to prefer the secondaries for backup. So it means that obviously our primary replica is not preferred, and that's why that's happening. We can, of course, change that. Now, I believe in the next piece of code, I talk about changing the backup priority. Let's just do this to 60 and see what happens. So 60 for server 3 to give it a higher weighting. So what has happened now? Which is preferred? Hopefully you would guess that we've only got one server which is now the preferred replica for backups. Clearly, because we've said we want to prefer secondaries and this has a higher weighting, clearly if this was no longer a secondary or no longer available, then that task or that preference would change to another server. So does this really work? So I've got a bit of code here, and let's just imagine that each one of these is running on SQL Server agent. Okay, but I'm essentially just connecting to each server and running the code. I'm testing, does the function say that this is a preferred replica? If it is, then backup, database and log, otherwise don't. And we are pushing this out to a shared location, which is important when we're talking about availability groups, to try and keep your backups in one place, which makes recovery a lot easier. Okay, so let's just run all of this code. Now you can see that it's done exactly what we were expecting, that in that it's ignored 2 because it wasn't preferred, but it's noticed that 3 is, backed it up, and then it's determined that 4 isn't the preferred, and so it's ignored that as well. So this is the kind of behavior you'd get in your SQL agent. And then one other thing to point out is about backup history, because this can be useful for recovery purposes, but let's have a look at what's going on across all the services. And if we go to server 3, we can see that we have had that backup for the database and log at these times, but you notice those entries do not exist in the other 2 replicas, or the other 2 instances, should I say, in MSDB. So this is another consideration if you're doing recovery, to make sure you check history of all the instances. And got a little exercise for you guys to try at home sometime. I'm not going to try this now for time purposes. Now the next demo we're going to do is we're going to have a quick look at read-only routing, which, as I've said to you, I've had problems in the past with this. But this is really down to my stupidity rather than problems with the technology, although I have to confess I'm not a big fan of the GUI of it. If we have a quick look, read-only routing here, it's not very intuitive at all what's going on here. There's a few tips, but it really isn't intuitive. So we're going to use code again. It's easy for you guys to replicate, and what we're going to do is modify our availability group, and for each replica we're going to put a secondary role read-only routing URL in. And then we're going to set the primary rule read-only routing to replicas, and you'll see here's our list. Note again that we have server 2, so if server 2 is the primary, we will want to route to server 3 or server 4 in our specific example, and server 3 we would route to server 2 or server 4. You don't have to have those, but that's what we want to do. Now I've had a few problems with this, where when you look at what you've just done, a lot of the time you don't get the information coming up. You see a little bit there, but it's not showing everything. Okay, I personally think this is a bit of a bug, but if we go on the if we actually have a look on the replicas themselves, notice that none of them are set as readable secondaries, so routing is clearly pointless and wouldn't work. So I actually want to set them all to read intent, which I've done. And now I'm hoping that we'll see all the information we've configured, and you'll see that this is the case. Sometimes you might not, and in which case you'd have to run this stuff above again if you don't see them. So now we've set up our readable replicas and our routing lists, so we're all good to go. So we've got a PowerShell script here, test. Oh, it's not test, is it? Let's see what it's called. So it's in PowerShell, and I'm going to just show you what it looks like. So readable secondary test. All it is a bit of PowerShell. We're just running a simple select command to see what server we're on at what time. We're going to try doing that. We've got a catch, would say if a connection's failed or not, and we've configured, if I just drag this here a little bit, we've configured the listener as in the connection string, and what database we're connecting to, and specified, if you remember, we have to specify application intent read only. Okay, so that's pretty good. So let's just run this now, and you'll see straight away we've returned server 3. That's pretty cool. But what happens if server 3 is unavailable? Have a think for a second. So what I'm going to do while you're thinking is I'm going to try and flick to Hyper-V, and we're going to pause server 3. So for server 3 is temporarily down. And let's just prove that. If we go into Cluster Manager, look at nodes, you'll see server 3 is down. If we look in our dashboard, and nothing's refreshed yet, but let's refresh now, you'll see that's detected it's down. It's not synchronizing because it's down. Obviously it's paused. So what happens if we run this code again? What did you say? If you said it was going to run straight away, you're obviously wrong. And be routed somewhere else, you're wrong. It fails. So your application has to handle errors still. Okay, connection problems, it still has to handle. But if it can do an intelligent retry, so let's just retry that failure, and you'll see we have automatically been routed to server 4. And that worked beautifully. So what I'm going to do now is flick back into Hyper-V and just resume. Okay. And hopefully our cluster will be clever enough to notice that the Windows node is back up and running. Cluster service will communicate again to the cluster saying I want to rejoin, which it's currently not. There we go, joining. Hit refresh one last time for good luck. And it's now back up and running. Notice also, you may have noticed the votes change. When we had 2 servers, only one of these servers had a vote. Now each one can cast a vote in the quorum. And if we go back into SQL Server, hopefully, as it is, synchronization is back up and running again. So that's really, really cool. And I believe that concludes those demos. So let's return back to the slides. So in summary, like, should you use availability groups or not? Because clearly you need some level of knowledge outside of SQL Server. Personally, I would say be careful before you adopt it. You need to have a cluster admin who knows what he's doing, and you need to understand the implications of clustering too. You need to really drag on board your cluster admin to your team and have a good discussion about what you want them to do here and how you do it, because generally clustering people don't understand SQL Server and vice versa. So it's not all butterflies and unicorns, okay? But I would say failover clustering, which is the technology that's working under the covers, at least to arbitrate some of the availability group resources, is a very, very mature technology. Okay, but it does require that specialist skill and understanding. And finally, if you do end up going to availability groups, you can rest assured that you have got quite a nice level of scalability in your SQL Server for reporting and those types of non-critical loads in which you don't have to have a transactional point in time consistency. Because remember, as I said, your secondaries may be ever so slightly behind, even in a synchronous mode replica. And they also provide a good level of HA and arguably a little bit of DR, because if a server blows up, then clearly if you have another synchronous replica, then you could get back to a point in time, because all those synchronous changes were captured in the transaction log. So I would argue that there is a certain level of DR introduced. So availability groups is a really nice technology. You need to know what you're doing, and you just need to be careful with how you roll it out and use it. So that wraps up my presentation. Thank you very much for bearing with me. I hope you enjoyed it. Hope you have a great day at SQL Bits, and peace. Please contact me if you need me. Take care.